section once for each value of the I and takes this, the value of I itself may or may not actually be used inside. You see, it's not necessary that you use I inside here. That's a very beautiful programming. Like when you are not using I, still you can repeat. Like if I say I start with the x is equal to 0.5 and put here x is equal to x plus 2. So then what will happen? It will take first x is 0.5 plus 2, 7. Then it comes again and then changes the value. X now becomes 2.5. So, and then 8. I have not used I here. But normally people use it. But sometimes if you are thinking you would like to do this, so this do loop basically repeats the segment calculation where you want between these two. Now here also there is another do loop, like you could put here a statement do 100 I is equal to, means repeat this calculation up to the statement 100 and then it comes automatically out after completing this number here. So the general form of the do statements in this case is value 1 comma value 2 and value 3. So that means, as I said, if there is nothing, that means the change will be followed by 1, 2, 3, 4. If there is any value, so that gives the interval. So the loop will execute for each value of the variable from value 1 to value 2 in steps of 3. Value 3 may be negative also or positive. Means you can reduce also from 10 to 1 and then you can write the minus 2. So it will take the change this by minus values, and so it can be, so it depends on the way you want to program. But this would be integer number. Value 3 may be negative or positive. If it is omitted, which is usually the case, then it's assumed to be 1. If you don't write this, then computer understands that it has to vary this variable. The computer variable must be integer type. This I do loop variable must be integer, I said. Value and value 2 and value 3 may be a constant, for example 100, or you could write expression also, like you could write 6 into 2 plus j, and j you give it. So then it also calculates this value and then it starts. So you could write here 1, 2, 6 start 2j plus 1. So suppose j is 2, so it becomes 4, 24. So it will take 20. Sometimes you require that this should be changed like that. So that fully you can exploit this do loop. So that is the one do loop where you are sure you want to change the value as demonstrated. Okay. Now there is then example here, right? We have written program lines, implicit, non-integer, and declare, do, and to 100. And you want to write this, so I must not talk in class, and the repeated section. So, and do is here, these are the comments. So it will, I must not talk, it will write 100 times because and changes from 1 and then it will talk 100 times, right? Because this is the value. You see, here I have not used any variable here. And this I is not going to bother because it's written in quotes. So that's it. Otherwise, okay, I is not here. N is not used anywhere. You can see this. So that is how you can, so it will write one time I must not talk in class, second time, third time. It's very dangerous sometimes if you are not using. Okay, let's go to the second type of program. Now you take integer I, okay, integer I, and declare this. Now do I 1 to 20 at the interval of 2. Now what will happen? That it will take 1, 3, 5, 7, 9, 11, 13. So all those values. And it writes here. Now you are writing here, start at I here and ji. You have to, j is not given, but you can give j is equal to 12. So it will, first it will write I and j star, so I changes and j. Now this is here, you are not modifying I, you are simply taking the multiplication here. In fact, it's I square. So it will square and write from first to these odd values, you see. So that is how you can use this. Everybody understands how to use this do loop?
Yes, sir.
Okay.
Yes,
now
sir.
there are other, so I can show you. You remember that in my calculation, I use this do loop statement. Now I have, I could write here and do here, but since I am, the best programmer, a coder is that who uses minimum number of statements. So the beauty of the program is that you make a program in such a manner that now if I have to make I could have written do and just not simply do I 1 n minus 1 to 2 and then n do here. So I can now I can say that 10 is the statement number. So as I said that these number up to 7 except 6 you can use here for a statement number. So now this do up to 10 statement number from 1 to n minus 1, and you see n is known from here because I have read already. So in Simpson rule, so it changes. No, I is not modified, it is used here. So I correct, so 4 times A is known, B is known, so it does this. And after doing this, then it is. So this program I had shown you, but now I show you that this do loop. There is another way to do. Instead of writing and do, you can write 10 continue. Continue statement simply is that go ahead. Okay. And if it is coupled with the do loop, like if you say 10 continue, I can remove this 10 and bring here and bring a statement 10 continue. So it will do the same job up to for the do loop. So continue is a trigger for it that go next value, and once the value reaches this one, then it comes out of the loop and does this. So this is how you can use in the program that I had used in the Simpson rule. You remember you had to change this there for different values. So now knowing this do loop statement, you can achieve this one. So you can see that I have used here. Now coming to, so one type of do loop, two type of do loops I have already told you. In one case, you could write do, don't tell, and just say and do, then it follows it. Then I told you that you can put a statement, do up to this statement, change I from here to here. Second, third type of is no determinist. You don't know that how many times you want to do it. For example, if there is a series convergence, you have to check. So you have to say when the term reaches 10 to the power, like you are adding something in a series. Let's say you are doing the calculation for e to the power x, and then 1 plus x upon factorial 1, 2, and so on. So all terms. So you can take one term, second term, third term, and it will add. And check that the term you are adding goes to a very small value, then you can say that the series has converged. So then you can use this do loop. Now here you are not saying what to do, how many looping you should do. So what will be done by the computer? It starts do loop, and there is an expression. If, for example, you have defined the term and then you can put that when the term is less than 10 to the power minus 6, exit. You write exit, so it comes out of the do loop. Okay, so that's the thing that you can control here by writing exit. Then, so this is non-determined. You don't know that when the situation is achieved, it will go out of the loop because you don't want to sum more terms in this series. So that is why you can write like this way, that if the, now here I forgot to tell you, you could do the same thing in this program. You can see that if you have put this value and you want to exit this program, like here, if I want to, for any reason I want to exit, then I can put a test here, for example, and I ask that in this, it's not required, but for example, in this, if you want to write only one time, 2 times, 3 times, it's 100 times here. So you could say that, okay, if n is less than 10, or even greater than 10, you could write here, then exit, you can write exit here, or go to 10. So then it comes to, if you want to control here, like if I say here in this do loop that for a particular value you don't want that its sum should be done. So you can check here if this sum is having some problem, you can say that go to 10, then it will skip this and comes to the 10 again here and does this. But if you say go to 20 or go to 15, it will come here. It will skip all this. So you can exit the do loop whenever you want by if statement. For any reason, if you see that, so that is allowed in any of the do loop. But in this case, you have to write the do loop. Otherwise, you know, earlier when there was problem of the computer time, because the computer could do the calculation taking a lot of time. Then if your condition is, this is very dangerous. If your condition is not met, then this will go on do looping, you know how many? Endless time. You start your calculation today, it will never end. जब तक कि कंप्यूटर बंद नहीं हो जाएगा. Because it does here, this expression is not coming, so it can't exit. It will do this way, this way, this way, it will do loop around. So many times the students make this type of mistake, give some wrong exiting, and they, when they are a little bit lazy, they say this is a better one. And the logical expression that you have given is never met while you are doing, then it will not exit. Or then, sir, मेरा तो program रुक ही नहीं रहा है, भूत लग गया है. So yeah, that's what you have to be careful about. You should be sure that this logical expression is going to be there. The form continues until some logical expression evaluates true, then it jumps out of the loop and continues with the code after. So it jumps out and goes further here. So after completing the do loop, it proceeds further. So okay, now there is a the same type of thing you could do. Like you want to check do while, you write while and then logical expression. So like you could write do I, and then while this value, you can say while I is 10. So is, or the, like here you could use the value that it should, instead of giving this value, you could simply say do, and okay, it can't be here, but let's see. Okay, so you can you know, make expression in such a manner that, so logical expression can be also here, that you know that, and then repeat this section ending. The form continues until some logical expression evaluates as a false. So when this condition is met, then it stops looping. Okay. Coming to the non-deterministic do loop are particularly good for summing power series. Looping stops when the absolute value of a term is less than some given tolerance. Single point iteration, looping stops when the changes is less than a given tolerance. So this is sometimes this is good to use at that time, that place. Okay. Now let's say that we have a problem. Let's apply this do loop understanding. Calculate the average and the standard. Yes, somebody is saying something.
Yes, sir. Sir, I was asking that can we use a variable in a do loop, like in the
Can you
third value, where
say clearly? Can we use? Yeah, say again.
can we use a variable in
Hmm.
value 3 of do loop?
Variable 3. What
So
does it mean?
variable in value 3. So you stated before, na, कि do loop takes three values. So the
Three
third
value?
value can be a,
Ah, yeah. You.
so
Oh, for the loop here you are saying. Like you see, I have used here three values. 1 to n minus 1 at the interval of 2 because I am doing this thing. So three values you can use, no problem, but you should be sure that this value is the loop will go first value and the at this interval. So 1, 3, 5 as well. This is what you were asking? Yeah, you could put 3, 5, whatever you like. Interval, maybe if you write 5 here, then it will be 1, 6, 11, 16, like this. Okay? Did I
yes, sir.
answer your question?
Yes,
Hello?
sir. Yes, sir.
Okay? Okay, so let's see. Now there are, you have to sum this series. Average value you have to calculate. If I give you 10 data, then you have to find the average of 10 values. So how and calculate the standard deviation. So average has to be, means you have to sum all the x values. First you have to read all the x values and then sum them and divide by number of values n. If you want to find out a standard deviation of this data set, like you have 1, 5, 20 or something, so you have to sum also, you have to sum of the square also and then divide by this formula set. Now, so first job is you have to find how many data are there. Now, if you are, suppose you get a file from, some rocket observation and you don't know, maybe the file is too big. So you don't know how many data are there and you want to sum. So what we do, let us put a negative data on our own at the, so in the beginning of the file, at the end of the file, there is one command, you can go at the end of the file and put yourself a negative data. And suppose all the data are positive, otherwise. So you see how I will do it. Calculate the average and the standard deviation. Calculate the average standard deviation of a set of measurements, assuming that all of the measurements are either positive or zero. Okay, that cannot be negative, suppose. In advance, how many measurements are included in the data set? A negative input value will mark the end of the set of the measurements. So I know that when the data becomes negative, that means now there are no more data. So how will you program? Now, you see, this is the problem given to you. Now, how will you do it? So first thing that I have to read all the data, or I read one by one and then count the value of the data. And then so I have to read the data, and then at the end, it tells me how many data it has read, and that will divide. And then I will so I need to calculate this expression and this expression simultaneously. And division things can be done afterwards. So once I find this sum, and so I can take sum x here and sum x2. You see, I have to define a variable. So I define sum x, sum x2. Sum x will be this and sum x2. It's a variable, but you see, I cleverly chose so that I know what does it mean, and then I will divide sum x by n, and I will divide sum x2 minus sum x here, and then sum x square. You see, it's a difference. It's the sum of square, and here sum of x and then square. So let's see. So I make a program. So now I say, like, first I have to give n. Now n is not known, so I put n is equal to 0 in the beginning. I define sum x, also it is in the beginning 0. So now I read x. Now it checks x immediately if x is less than 0 or not. If it is less than 0, then it comes out, and then just whatever value these expressions are calculated afterwards. So x bar and standard calculate this and write those values and stop. That is what a program. Now, if it is not less than, then proceed further. And then that means if statement met, that means it's true, then you have to, because the number of n, how I do it. Now here I make n, I started with 0, so n is equal to n plus 1. So 0 will be n is equal to n plus 1. And this is 0 I said, so I will sum. So it will read x value, and it will change the n from 0 to 1 and also add x. And then again it goes in the do loop, reads the second data, checks again, and then n it becomes 2. And then it sums sum x plus x. So now the new sum x will be here. And so it does this. After it is done, it meets the last data, it comes out and gives you the result. Now, this is the block diagram I have made. Now I want to make a real program. So here, now program, yes.
Sir, can you please tell the statement, sir, previous slide, sir. After the false statement, what logic was there?
Or you just write if, and then if x dot and lt dot 0.0. Okay, 0.0. Yes. That means it's a negative. Naturally, it will be less than. Then what you have to do, out of the bracket, you write go to 10, and then you can give this 10 statement number. That's the one way to do it. Okay, then it proceeds further. So let us see, one of the way that the program is made is here. First, as I said, fix this value, integer, n is integer, and that is equal to 0. ST standard deviation I have denoted by, you see, always denote in such a manner that you know what it would be. So I denoted this, so I know it gives you standard deviation. Initialize it to 0. Sum x is also 0. Sum x2 is also a square. And real x is also 0. Real x bar is also 0. Let's see how it does then. Now, read do. Now, do is now logical. So it will check, and if it is negative, it will exit automatically, or I have to give this. So, read the next value, write, enter the number. Write, as I said, that you can read and write both the things. Here, if you have written like this, it asks you write the number, because you are not reading from a file. So you type first number is 1, second number is 3, or you are giving the data on the screen. Then number is x, right? Number. So first it asks, is a echo here. You are saying that enter the number. So you enter number, and then, so you have created, computer is not doing anything. You have made your program that instructs you. Now data is required, first data. Then after reading this, it writes this, so you can check that what you have entered is taken by the. Now the do loop is checked here. So do has started, and if x is less than this, get out of the loop, go out of the loop. So long x is positive, then it does. So suppose it's positive, it goes, makes n to n plus 1. This was earlier 0, x was, now it has read the x value, so it puts here. Now it x square is put here, this was also 0, and then it goes there and then comes here again. Again asks second value, you type second value, text again whether the second value is negative. If not, it goes further, makes n is equal to, now the next value is 2. So 2 plus 1 is 3. And here sum is, whatever the sum was earlier x, now it becomes 2x. And this was x square, so another x square. And then it does it. So it do loops, and you gives you the sum of the x value, sum of the x square value. Now the time is to time. So x bar is equal to sum bar x divided by real n. It's just to avoid any problem of real divided by integer, better make all real here. So real n. And then standard deviation is given by square root, real n, sum x, this. So this is the expression which I have written. So I can type these two expressions there. Now here is the value. I say the write down the mean of the data. It quotes, so it writes exactly this value and x bar. The standard deviation is standard deviation. The value number of the data point is n, and that's it. Your program finishes here. So you can see we have utilized here a do loop, which is a non-deterministic, and it decides there itself that which value it should take. Let's take another program. The same thing, how I do it. Again, I initialize this value to 0, and then write get the number of points to input. So write enter the number of points, it says. So now here you can read n also. In this program, n was kept 0. Now in this program, suppose I know how many data are there. So enter the number of points. If you know that number of data, and that is not very difficult, you know how many lines are there. So here your checkpoint is read n. So now you are telling I have 95 data. So it asks, you write 95, so n becomes 95 when it reads. Check to see if we have enough input data. I mean, doing averaging usually if you don't have data, even 2 data. So if you say n is less than, then you just write at least two values must be entered. So it's just fancy type of else. Otherwise, then it proceeds further in the second page here. Now it uses the do loop 1 where you know the n value. Now because you gave it read the n values and then now it reads first data and does the same thing here, and then do loop is finished when n is done, and then so you saw that the second do loop that you can also like this. If you know the data, you do it. If you don't know the data, because it's a huge file, then you can just you can go at the end of the data, put negative value, and so it depends on you how you want to do. Okay, now this was that you want to repeat a segment where the calculation like x was to be added and x squared was to be added and data were read, and you are doing this. Now if suppose you have the two variable that you want to add involved in this. So now, like in matrix, you will do the same thing, that there will be row and column. So how you do it when you have two set of data? So first you have to make integer ij and its product. So there are two data, you would like to have a product of this. So do I 1 to 3. You could, because you know there are three data, so you just write do I 1 to 3. And immediately do j 1 to 3. Suppose this is 3. Then what happens? The product will be I star j. And write I star j. So it will be just written as such. I value will be written, then star will be printed because it's in quotes, and j value equal. And the product is this. So product will be. It will do this. Here, first it will complete this value. First inner loop will be completed. So that means for one value of I, which is 1, it takes the 1, 2, 3, and so on. When 3 is done, then it takes the second value of this, then all the values of j here. And so it will do this sort of calculation. And so here one thing you have to note, that if you are using two do loops, then the do loop which is comes at the end should close first. So that means you can't do that. This do loop has started, and so you have to follow a reverse procedure. The one which occurs this should be closed first, and then otherwise immediately computer will say the do loop nesting is incorrect and stop. It will tell you the do loop nesting has been, nesting means the like you have involved there, this is incorrect, and it will stop. So now how it will do, I can show you how product will be written. It reads the I, makes it I 1, so 1. Then 1 is star 1, j is 1, so you get 1. Product will be, so you are writing I, j, and 1. So it is right as such star and then 1. Now it takes the second value here. So first value still remains the second, value changes. So j changes here. So 1, 2, 3, and the product will be. Then after 3 values taken, then it will go there. I will be 2, and then all the j values. Then I will be 3, and after that you see. So this is what you will get the output. So this is what, and now you should very clearly understand that how do loop works. That means you should not confuse, like it started here and then here, then this will be done first. No, inner loop is completed first, inner should be closed first, and then the outer loop will be closed. So what is there now? The if you have, for example, used 100 continuous, so you can put 100 here. And if you want to use 100 here and 200 here statement, that's also done. Then 200 continue will come first and 100 will go at the end, depending on how you do loop. Here again, you can use the logical statement. So this is what, or you could identify, as I said, you could identify the loop by doing this way. So inner do and do inner first. So, or as I said, you can use the statement number and then you could write this. So if you are confused, then better do this way or use the statement here. There are no confusion. As I said, sometimes you have 5 do loops and then confused which one is closing, which one is not closing, and the result is computer is going on running in all the loops. If any of the loops, the condition is not met, then computer will go for its life until you shut down the computer. So do loop is very risky. You have to sure that what do loop you want to use. Here it is, you can use 3 do loops. So the variable would be different. You can't use the same variable. So do loop is 1 to 10 here. You can take this 20, it's not, and then loop 3, do k. You see, this do loop is known, and then you could use these also inside. Do k, like if you do the matrix multiplication, then you need this type of do loop. So like row and column, and then you remember that in matrix Aij and then Ji, Jk. So if you multiply Ij matrix, then you can multiply Jk matrix. So total product will be Ik matrix. So as you know this. So this is the same thing that is shown here that you can do, and loop 3 started at the end. Now this, is it correct to loop? Tell me. It's wrong.
No, sir.
Why wrong?
No, sir, it's
Because
wrong.
do
Because
loop start, yeah, it should be at the end. So you have to reverse it. Do loop 3, then 2, then 1. So it indicates the reason why they are invalid. That's what is written here. Okay. Now, what is wrong here? It should be the correct way is like this. Then I have another do loop here. So either you can identify do loop X and do loop. Is it wrong here?
Yes, sir.
Yes, sir.
Yeah, it's wrong because why do loop Y should be force close and then. So that's what you have to be sure. Now these are the problems. Okay. Now input output I will tell you in the next lecture how to.
sir, I have a doubt.
read. Yeah, tell me.
Sir, please go to the previous slide, in which you print the numbers or previous as well. सर एक और स्लाइड पीछे जाइए. नहीं सर, लास्ट इससे और पीछे. यस सर, और प्रीवियस और प्रीवियस. हाँ सर, यहाँ पे हम जो ब्लैंक स्पेसेस हैं उनको रिमूव नहीं कर सकते क्या?
क्यों नहीं?
लाइक जो स्टार.
You see, this is these blank spaces are maybe while I made this slide, the tab was there, but they will not make this much of difference. Okay, so it will be very close here. There's not going to be any gap. In fact, there will be no gap. You have to arrange. Yeah. No, it's not going
I thought
to
that the program result. Yes, sir, I thought the program result is like it, that it is printing this space by default.
Not program. This is what I will tell you in the next lecture, that when you write this, here you see
Input output.
why it's making this, because I am writing the output here. So when you are writing this, so I take I here, so 1 is written. Now this gap, I mean, if I make more gap, then this will be written more gap. So if you are continuous quotes, then it will not give them. Then also like J is written here, so you can see first J will be written, equal is written. So if there are more gaps here, they will. So it is up to you. Now next lecture will be based on how to write, how to read the data. So this will not be there. Okay?
Okay, sir. Thank you.
So in this example, you
Hmm.
have written do I is equals to 1 comma 3, but so you have specified here I, but in the previous one where we were talking about standard deviation, so you had not defined n anywhere. So how the computer got to know that we are talking about n?
That's what I said. That when this is the beauty, it only meaning is that here I have not used because I am going to use the logic here. So it's not necessary. I did not define here n. You see, I rather know from the computer what is n because I don't know how many data are there. So that's what I told you. So I start with 0 and if I give this statement and print here n, at the end I will know how many data were there. You see, I am writing here the x bar is standard and number of data n here. So if you don't know, it can tell you. So because I don't know, suppose there is a, the ISRO takes the height-wise data of the density of atmosphere or space, and then you take some data, and it's difficult to count that. But normally, if you make a file, you know how many data are there. But suppose you don't know, why to bother? Just go at the end of the file, put a negative quantity and then it will tell you how to. If you know, then you can use this. But it is
And
not
so in
used here. That is the point. That's what I said. Its purpose is simply to repeat from here to here. It's not purpose. Whether like even in this example that I gave you, and I told you like you may not use this n inside. N may not be used. So this is how you can repeat it. So n will go here, but you know that you want to repeat it 100 times. So that's what I said. If you don't want to use, don't use it. But normally people use it when they are defined. Like here, I is used. But if it is not, then no problem. You can, but you can't modify this. You can use this, try to understand, you can use this variable. Like here I am multiplying I and I, but I'm not changing the value of the I here. Like you can't make I is equal to I plus 1 or something. Then it will object to it and say, you can't modify the variable of do loop. Okay?
Yes, sir. So one more thing. So you have assigned the value n is equals to 0. So we should assign it 1 because we are starting with the first data. So why you have assigned 0?
No, yeah, you can decide that the first data, you can, when you will assign 1, then it reads the data, then it becomes 2. So how your purpose is to add this data here. So let's see. Now, if you assign 1, then it will become 2, even in the first data. So somewhere you have to leave it. So it's better to define 0. If you want to 1, then how will you? Then you have to give in the do loop that something like it doesn't take 1 because you have already defined here. Okay. So if you have to do this thing, then you have to take 1. Otherwise, it will create problem. Okay. Did you follow what I said?
Yes, sir.
Anyone? Okay, then I stop and you may go. to your next lecture. So next lecture will be on Tuesday.
Sir, the questions that you have included in the slides, those are for our practice, or will you be explaining them in the next class?
Where?
The presentation had some questions, right? Like tension and those right now.
Yeah, I will give you as a tutorial sheet next separately.
Okay,
Here,
sir,
then I have to stop here and start discussing this. So that's why I gave like that. Okay?
yes, sir, understood.
I will give you another sheet where I will mention this.
Thank you,
Okay
sir.
then.
Okay, thank you, sir.
Okay, welcome. Asiya Batul, is she here?